Jonathan Brendefur from DMTI, and we're going to talk about division. This time we're going to talk about division of fractions. So there's another video that just talks about division with whole numbers, and we use this context, the situation, with the numbers 3 and 2, 3 divided by 2. So now we're going to replace the numbers and do 3 divided by half, 3/4 divided by half, 1/4 divided by 1/2. So if you're working with students, you may want to stop and have them replace the numbers. I have run 3 miles so far, so the 3 stays the same. I am running, and now in this case, I'm running 1/2 mile intervals. So we're going to change out that number. How many intervals have I completed? And we're going to do that for all 3 problems. And so you can stop, pause for a second, then come back. We'll talk about how do you model this with a bar model, and then how can you explain what each aspect of the division problem actually means. Okay, if you're coming back, so the 3 is going to be our dividend. It's going to be the amount that we have. And I'm going to model that with a bar model. And I have a 3, partition that into 3 equal sections, 1 and 2. But this case now, the divisor is going to tell us that we are now, the question I like asking all the time when we're with division is, how many halves fit into 3? So here, how many half-mile intervals? Well, in this case, I have to look, an interval is going to be a 1/2 mile. So that is, here, there's a new 1. So this was 1, these are miles, and these are intervals. So it takes 1 interval for 1/2 mile. It's going to take 2 to go 1 mile, 2 halves. Now I'm just going to build this out, 3 halves, 4 halves, 5 halves, 6 halves. So we have that all the way. So that's 2 intervals, 3 intervals, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. So 3 divided by half is going to be 6 intervals. And here you can see the relationship as well. If you change this over to 3 times 2/1, where do you start seeing that? So here, the 3 divided by half, you can see the 6 halves here. Over here, you're looking at for every 2 halves, there's 2, and you're going to do that 1, 2, 3. So there's that explanation with that inverse operation of why is 3 divided by half the same as 3 times 2. Okay, we're going to pause for a second, and then we're going to work on this one. So have your kids maybe work on this one next. And now let's take and look at that example. Okay, in this case, we're going to replace the dividend here, 3/4. So now we would read this as, I've run 3/4 of a mile so far. I am running 1/2 mile intervals. How many intervals have I completed? Okay, now let's look at this case. So now I'm going to build my model out, and I'm going to do it all the way to 1 so I can build the 3/4 where the denominator is going to tell me to partition my unit of 1 into 4 equal sections. Noticing that we're not using the word whole, but just talking about 1, because we're referring to 1. That really helps with division. We have a count of 3 of them. So there's 1/4, 2/4, 3/4, and that 1 is 4/4. I'm going to replace that just a little bit here to be consistent. And I have, there's my 3/4 that I've run, 3/4. Now I'm running 1/2 mile intervals. So now if I look here, here is my 1/2 mile. That is 1 interval. So here's my miles. Here's my intervals. I've run 1 interval. If I go again, all the way here is going to be 2 intervals. I've only run 3/4 mile, so here, partition this, how many intervals I've run. Here's a 1/2, 2 halves of an interval, and 3 halves. So I have run right there 3 halves or 1.5 intervals. And notice that this force, the 3/4, is referring to the miles, 1 mile. Now we're referring to the 1 interval. So again, it's relative to which one that we're referring to, which makes fractions sometimes mysterious. So here we could change that to 3/4 times 2/1, and then we still get that same relationship, which is that 6/4, or the 3 halves or 1.5 or intervals. Okay, pause here. Let's do one more. So now the dividend is actually smaller. So let's take a look at what that looks like. Okay, so now we're gonna erase our numbers here. So now I've run 1/4 of a mile. So far, I'm running 1/2 intervals. How many intervals have I completed now? So same type of work. I'm gonna map out 1 mile over here, but I've only run a 4, so I'm gonna partition my 1 into 4 equal sections. There's my 1/4, 2/4, 3/4, 4/4. Here, I've only run this amount. Now again, the divisor, one way of looking at it is to measure it. So I have a 1/2 a mile scoop here. So the 2/4 and the 1/2 are the same. So I'm wondering how much here have I run of an interval. So here I haven't even run 1 interval. I've only run 1/2 of an interval. So 1/4, how far I've run out of my interval is 1/2. We could, again, 1/4 times 2/1 is equal to 2/4. And that is still, what we're focused on is the 1/2 of an interval. So either way, we're going to get the same answer. The 2/4 is still equal to the 1/2. But what this does is the modeling with the language makes it very clear about what division of fractions means, where we don't get these confused, where we're flipping the fractions, we're doing the intervals, and then we build a lot of misconceptions. We don't want those misconceptions. That's why the language and the modeling is so critical, especially on these easier number sets. Then you can start moving towards the algorithms later once you have built that deep understanding. So hopefully that was helpful in understanding division of fractions.